Hello everyone. Question is a company requires that its internally facing web application be highly available. The architecture is made up of one Amazon EC2 web server instance and one NAT instance that provides outbound internet access for updates and accessing public data. Which combination of architecture adjustments should the company implement to achieve high availability? Choose two options. Option A: add the NAT instance to an EC2 auto-scaling group that spans multiple availability zones. Update the route tables. Option B: create additional EC2 instances spanning multiple availability zones. Add an application load balancer to split the load between them. Option C: configure an application load balancer in front of the EC2 instance. Configure Amazon CloudWatch alarms to recover the EC2 instance upon host failure. Option D: replace the NAT instance with a NAT gateway in each availability zone. Update the route tables. Option E: replace the NAT instance with a NAT gateway that spans multiple availability zones. Update the route tables. Correct answer is option B and option E. Question is a DevOps engineer is building a multi-stage pipeline with AWS code pipeline to build, verify, stage, test, and deploy an application. A manual approval stage is required between the test stage and the deploy stage. The development team uses a custom chat tool with webhook support that requires near real-time notifications. How should the DevOps engineer configure status updates for pipeline activity and approval requests to post the chat tool? Option A: create an Amazon CloudWatch logs subscription that filters on code pipeline execution state change. Publish subscription events to an Amazon simple notification service, Amazon SNS topic. Subscribe the chat webhook URL to the SNS topic and complete the subscription validation. Option B: create an AWS Lambda function that is invoked by AWS CloudTrail events. When a code pipeline execution state change event is detected, send the event details to the chat webhook URL. Option C: create an Amazon Event Bridge rule that filters on code pipeline execution state change. Publish the events to an Amazon simple notification service, Amazon SNS topic. Create an AWS Lambda function that sends event details to the chat webhook URL. Subscribe the function to the SNS topic. Option D: modify the pipeline code to send the event details to the chat webhook URL at the end of each stage. Parameterize the URL so that each pipeline can send to a different URL based on the pipeline environment. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is a company's application development team uses Linux-based Amazon EC2 instances as Bastion hosts. Inbound SSH access to the Bastion host is restricted to specific IP addresses as defined in the associated security groups. The company's security team wants to receive a notification if the security group rules are modified to allow SSH access from any IP address. What should a DevOps engineer do to meet this requirement? Option A. Create an Amazon Event Bridge rule with a source of AWS.CloudTrail and event name. Authorize security group Incase. Define an Amazon Simple Notification Service Amazon SNS topic as the target. Option B. Enable Amazon Guard Duty and check the findings for security groups in AWS Security Hub. Configure an Amazon Event Bridge rule with a custom pattern that matches Guard Duty events with an output of non-compliant. Define an Amazon Simple Notification Service Amazon SNS topic as the target. Option C. Create an AWS config rule by using the restricted SSH managed rule to check whether security groups disallows unrestricted incoming SSH traffic. Configure automatic remediation to publish a message to an Amazon Simple Notification Service Amazon SNS topic. Option D. Enable Amazon Inspector. Include the common vulnerabilities and exposures 1.1 rules package to check the security groups that are associated with the Bastion hosts. Configure Amazon Inspector to publish a message to an Amazon Simple Notification Service Amazon SNS topic. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a DevOps team manages an API running on premises that serves as a backend for an Amazon API gateway endpoint. Customers have been complaining about high response latencies, which the development team has verified using the API gateway latency metrics in Amazon CloudWatch. To identify the cause, the team needs to collect relevant data without introducing additional latency. Which actions should be taken to accomplish this? Choose two options. Option A. Install the CloudWatch agent server side and configure the agent to upload relevant logs to CloudWatch. Option B. Enable AWS X-ray tracing in API Gateway. Modify the application to capture request segments and upload those segments to X-ray during each request. Option C. Enable AWS X-ray tracing in API Gateway. Modify the application to capture request segments and use the X-ray daemon to upload segments to X-ray. Option D. Modify the on-premises application to send log information back to API Gateway with each request. Option E. Modify the on-premises application to calculate and upload statistical data relevant to the API service request to CloudWatch metrics. Correct answer is option B and option C. Question is, a company has an application that is using a MySQL compatible Amazon Aurora Multi-AZ DB cluster as the database. A cross-region read replica has been created for disaster recovery purposes. A DevOps engineer wants to automate the promotion of the replica so it becomes the primary database instance in the event of a failure. Which solution will accomplish this? Option A. Configure a latency-based Amazon Route 53 CNAME with health checks so it points to both the primary and replica endpoints. Subscribe an Amazon SNS topic to Amazon RDS failure notifications from AWS CloudTrail and use that topic to invoke an AWS Lambda function that will promote the replica instance as the primary. Option B. Create an Aurora custom endpoint to point to the primary database instance. Configure the application to use this endpoint. Configure AWS CloudTrail to run an AWS Lambda function to promote the replica instance and modify the custom endpoint to point to the newly promoted instance. Option C. Create an AWS Lambda function to modify the application's AWS CloudFormation template to promote the replica. Apply the template to update the stack and point the application to the newly promoted instance. Create an Amazon CloudWatch alarm to invoke this Lambda function after the failure event occurs. Option D. Store the Aurora endpoint in AWS Systems Manager parameter store. Create an Amazon Event Bridge event that detects the database failure and runs an AWS Lambda function to promote the replica instance and update the endpoint URL stored in AWS Systems Manager parameter store. Code the application to reload the endpoint from parameter store if a database connection fails. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company hosts its staging website using an Amazon EC2 instance backed with Amazon EBS storage. The company wants to recover quickly with minimal data losses in the event of network connectivity issues or power failures on the EC2 instance. Which solution will meet these requirements? Option A. Add the instance to an EC2 auto-scaling group with the minimum, maximum, and desired capacity set to 1. Option B. Add the instance to an EC2 auto-scaling group with a lifecycle hook to detach the EBS volume with the EC2 instance shuts down or terminates. Option C. Create an Amazon CloudWatch alarm for the status check failed system metric and select the EC2 action to recover the instance. Option B. Create an Amazon CloudWatch alarm for the status check failed instance metric and select the EC2 action to reboot the instance. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company wants to use AWS development tools to replace its current bash deployment scripts. The company currently deploys a lab application to a group of Amazon EC2 instances behind an application load balancer ALB. During the deployments, the company unit tests the committed application, stops and starts services, unregisters and re-registers instances with the load balancer, and updates file permissions. The company wants to maintain the same deployment functionality through the shift to using AWS services. Which solution will meet these requirements? Option A. Use AWS code build to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services and deregister and register instances with the ALB. Use the appspec.yml file to update file permissions without a custom script. Option B. Use AWS code pipeline to move the application from the AWS code commit repository to AWS code deploy. Use code deploys deployment group to test the application. Unregister and re-register instances with the ALAND restart services. Use the appspec.yml file to update file permissions without a custom script. Option C. Use AWS code pipeline to move the application source code from the AWS code commit repository to AWS code deploy. Use code deploy to test the application. Use code deploy's appspec.yml file to restart services and update permissions without a custom script. Use AWS code build to unregister and re-register instances with the ALB. Option D. Use AWS code pipeline to trigger AWS code build to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services. Unregister and re-register the instances in the AWS code deploy deployment group with the ALB. Update the appspec.yml file to update file permissions without a custom script. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company runs an application with an Amazon EC2 and on-premises configuration. A DevOps engineer needs to standardize patching across both environments. Company policy detects that patching only happens during non-business hours. Which combination of actions will meet these requirements? Choose three options. Option A. Add the physical machines into AWS Systems Manager using Systems Manager hybrid activations. Option B. Attach an IAM role to the EC2 instances, allowing them to be managed by AWS Systems Manager. Option C. Create IAM access keys for the on-premises machines to interact with AWS Systems Manager. Option D. Run an AWS Systems Manager automation document to patch the systems every hour. Option E. Use Amazon Event Bridge scheduled events to schedule a patch window. Option F. Use AWS Systems Manager maintenance windows to schedule a patch window. Correct answer is option A, E, and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has chosen AWS to host a new application. The company needs to implement a multi-account strategy. A DevOps engineer creates a new AWS account and an organization in AWS organizations. The DevOps engineer also creates the OU structure for the organization and sets up a landing zone by using AWS Control Tower. The DevOps engineer must implement a solution that automatically deploys resources for new accounts that users create through AWS Control Tower Account Factory. When a user creates a new account, the solution must apply AWS CloudFormation templates and SCPs that are customized for the OU or the account to automatically deploy all the resources that are attached to the account. All the OUs are enrolled in AWS Control Tower. Which solution will meet these requirements in the most automated way? Option A. Use AWS Service Catalog with AWS Control Tower. create portfolios and products in AWS Service Catalog, grant granular permissions to provision these resources, deploy SCPs by using the AWS CLI and JSON documents. Option B. Deploy CloudFormation stack sets by using the required templates. Enable automatic deployment. Deploy stack instances to the required accounts. Deploy a CloudFormation stack set to the organization's management account to deploy SCPs. Option C. Create an Amazon Event Bridge rule to detect the Create Managed Account event. Configure AWS Service Catalog as the target to deploy resources to any new accounts. Deploy SCPs by using the AWS CLI and JSON documents. Option D. Deploy the customizations for AWS Control Tower CFCT solution. Use an AWS code commit repository as the source. In the repository, create a custom package that includes the CloudFormation templates and the SCP JSON documents. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, an online retail company based in the United States plans to expand its operations to Europe and Asia in the next 6 months. Its product currently runs on Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto-scaling group across multiple availability zones. All data is stored in an Amazon Aurora database instance. When the product is deployed in multiple regions, the company wants a single product catalog across all regions. But the compliance purposes, its customer information and purchases must be kept in each region. How should the company meet these requirements with the least amount of application changes? Option A. Use Amazon Redshift for the product catalog and Amazon DynamoDB tables for the customer information and purchases. Option B. Use Amazon DynamoDB global tables for the product catalog and regional tables for the customer information and purchases. Option C. Use Aurora with read replica for the product catalog and additional local Aurora instances in each region for the customer information and purchases. Option D. Use Aurora for the product catalog and Amazon DynamoDB global tables for the customer information and purchases. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a rapidly growing company wants to scale for developer demand for AWS development environments. Development environments are created manually in the AWS Management Console. The networking team uses AWS CloudFormation to manage the networking infrastructure, exporting stack output values for the Amazon VPC and all subnets. The development environments have common standards such as application load balancers, Amazon EC2 auto-scaling groups, security groups, and Amazon DynamoDB tables. To keep up with demand, the DevOps engineer wants to automate the creation of development environments. Because the infrastructure required to support the application is expected to grow, there must be a way to easily update the deployed infrastructure. CloudFormation will be used to create a template for the development environments. Which approach will meet these requirements and quickly provide consistent AWS environments for developers? Option A. Use FN import value intrinsic functions in the resources section of the template to retrieve Visual Private Cloud VPC and subnet values. Use CloudFormation stack sets for the development environments, using the count input parameters to indicate the number of environments needed. Use the update stack set command to update existing development environments. Option B. Use nested stacks to define common infrastructure components. To access the exported values, use template URL to reference the networking team's template. To retrieve Virtual Private Cloud VPC and subnet values, use FN import value intrinsic functions in the parameters section of the root template. Use the create change set and execute change set commands to update existing development environments. Option C. Use nested stacks to define common infrastructure components. Use FN import value intrinsic functions with the resources of the nested stack to retrieve Virtual Private Cloud VPC and subnet values. Use the create change set and execute change set commands to update existing development environments. Option D. Use FN import value intrinsic functions in the parameters section of the root template to retrieve Virtual Private Cloud VPC and subnet values. Define the development resources in the order they need to be created in the CloudFormation nested stacks. Use the create change set and execute change set commands to update existing development environments. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company uses AWS organizations to manage multiple accounts. Information security policies require that all unencrypted Amazon EBS volumes be marked as non-compliant. A DevOps engineer needs to automatically deploy the solution and ensure that this compliance check is always present. Which solution will accomplish this? Option A. Create an AWS CloudFormation template that defines an AWS inspector rule to check whether EBS encryption is enabled. Save the template to an Amazon S3 bucket that has been shared with all accounts within the company. Update the account creation script pointing to the CloudFormation template in Amazon S3. Option B. Create an AWS config organizational rule to check whether EBS encryption is enabled and deploy the rule using the AWS CLI. Create and apply an SCP to prohibit stopping and deleting AWS config across the organization. Option C. Create an SCP in organizations. Set the policy to prevent the launch of Amazon EC2 instances without encryption on the EBS volumes using a conditional expression. Apply the SCP to all AWS accounts. Use Amazon Athena to analyze the AWS CloudTrail output, looking for events that deny an EC2 run instances action. Option D. Deploy an IAM role to all accounts from a single trusted account. Build a pipeline with AWS Code Pipeline with a stage in AWS Lambda to assume the IAM role and list all EBS volumes in the account. Publish a report to Amazon S3. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has deployed an application in a production VPC in a single AWS account. The application is popular and is experiencing heavy uses. The company's security team wants to add additional security such as AWS WAF to the application deployment. However, the application's product manager is concerned about cost and does not want to approve the change unless the security team can approve that additional security is necessary. The security team believes that some of the application's demand might come from users that have IP addresses that are on a deny list. The security team provides the deny list to a DevOps engineer. If any of the IP addresses on the denial list access the application, the security team wants to receive automated notification in near real time so that the security team can document that the application needs additional security. The DevOps engineer creates a VPC flow log for the production VPC. Which set of additional steps should the DevOps engineer take to meet these requirements most cost effectively? Option A. Create a log group in Amazon CloudWatch logs. Configure the VPC flow log to capture accepted traffic and to send the data to the log group. Create an Amazon CloudWatch metric filter for IP addresses on the deny list. Create a CloudWatch alarm with the metric filter as input. Set the period to 5 minutes and the data points to alarm to 1. Use an Amazon Simple Notification Service Amazon SNS topic to send alarm notices to the security team. Option B. Create an Amazon S3 bucket for log files. Configure the VPC flow log to capture all traffic and to send the data to the S3 bucket. Configure Amazon Athena to return all log files in the S3 bucket for IP addresses on the deny list. Configure Amazon QuickSight to accept data from Athena and to publish the data as a dashboard that the security team can access. Create a threshold alert for 1 for successful access. Configure the alert to automatically notify the security team as frequently as possible when the alert threshold is met. Option C. Create an Amazon S3 bucket for log files. Configure the VPC flow log to capture accepted traffic to send the data to the S3 bucket. Configure an Amazon OpenSearch service cluster and domain for the log files. Create an AWS Lambda function to retrieve the logs from the S3 bucket, format the logs, and load the logs into the OpenSearch service cluster. Schedule the Lambda function to run every 5 minutes. Configure an alert and condition in OpenSearch service to send alerts to the security team through an Amazon Simple Notification Service Amazon SNS topic when access from the IP addresses on the denial list is detected. Option D. Create a log group in Amazon CloudWatch logs. Create an Amazon S3 bucket to hold query results. Configure the VPC flow log to capture all traffic and to send the data to the log group. Deploy an Amazon Athena CloudWatch connector in AWS Lambda. Connect the connector to the log group. Configure Athena to periodically query for all the accepted traffic from the IP addresses on the deny list and to store the results in the S3 bucket. Configure an S3 event notification to automatically notify the security team through an Amazon Simple Notification Service Amazon SNS topic when new objects are added to the S3 bucket? Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a development team wants to use AWS Cloud Formation stacks to deploy an application. However, the developer IAM role does not have the required permissions to provision the resources that are specified in the AWS Cloud Formation template. A DevOps engineer needs to implement a solution that allows the developers to deploy the stacks. The solution must follow the principle of least privilege. Which solution will meet these requirements? Option A, create an IAM policy that allows the developers to provision the required resources. Attach the policy to the developer IAM role. Option B, create an IAM policy that allows full access to AWS Cloud Formation. Attach the policy to the developer IAM role. Option C, create an AWS Cloud Formation service role that has the required permissions. Grant the developer IAM role a cloud formation action. Use the new service role during stack deployment. Option D, create an AWS Cloud Formation service role that has the required permissions. Grant the developer IAM role that the IAM pass role permission. Use the new service role during stack deployments. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company must encrypt all AMIs that the company shares across accounts. A DevOps engineer has access to a source account where an unencrypted custom AMI has been built. The DevOps engineer also has access to a target account where an Amazon EC2 auto-scaling group will launch EC2 instances from the AMI. The DevOps engineer must share the AMI with the target account. The company has created an AWS Key Management Service AWS KMS key in the source account. Which additional steps should the DevOps engineer perform to meet the requirements? Choose three options. Option A, in the source account, copy the unencrypted AMI to an encrypted AMI. Specify the KMS key in the copy action. Option B, in the source account, copy the unencrypted AMI to an encrypted AMI. Specify the default Amazon Elastic Block Store Amazon EBS encryption key in the copy action. Option C, in the source account, create a KMS grant that delegates permissions to the auto-scaling group service linked role in the target account. Option D, in the source account, modify the key policy to give the target account permissions to create a grant. In the target account, create a KMS grant that delegates permissions to the auto-scaling group service linked role. Option E, in the source account, share the unencrypted AMI with the target account. Option F, in the source account, share the encrypted AMI with the target account. Correct answer is option A, D and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company's developers use Amazon EC2 instances as remote workstations. The company is concerned that users can create or modify EC2 security groups to allow unrestricted inbound access. A DevOps engineer needs to develop a solution to detect when users create unrestricted security group rules. The solution must detect changes to security group rules in near real time, remove unrestricted rules, and send email notifications to the security team. The DevOps engineer has created an AWS Lambda function that checks for security group ID from input, removes rules that grant unrestricted access, and send notifications through Amazon's simple notification service, Amazon SNS. What should the DevOps engineer do next to meet the requirements? Option A. Configure the Lambda function to be invoked by the SNS topic. Create an AWS CloudTrail subscription for the SNS topic. Configure a subscription filter for security group modification events. Option B. Create an Amazon Event Bridge scheduled rules to invoke the Lambda function. Define a schedule pattern that runs the Lambda function every hour. Option C. Create an Amazon Event Bridge event rule that has the default event bus as the source. Define the rules event pattern to match EC2 security group creation and modification events. Configure the rule to invoke the Lambda function. Option D. Create an Amazon Event Bridge custom event bus that subscribes to events from all AWS services. Configure the Lambda function to be invoked by the custom event bus. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, an IT team has built an AWS Cloud Formation template so others in the company can quickly and reliably deploy and terminate an application. The template creates an Amazon EC2 instance with a user data script to install the application and an Amazon S3 bucket that the application uses to serve static web pages while it is running. All resources should be removed when the CloudFormation stack is deleted. However, the team observes that CloudFormation reports an error during stack deletion, and the S3 bucket created by the stack is not deleted. How can the team resolve the error in the most efficient manner to ensure that all resources are deleted without errors? Option A. Add a deletion policy attribute to the S3 bucket resource, with the value delete forcing the bucket to be removed when the stack is deleted. Option B. Add a custom resource with an AWS Lambda function with the depends on attributes specifying the S3 bucket and an IAM role. Write the Lambda function to delete all objects from the bucket when request type is delete. Option C. Identify the resource that was not deleted. Manually empty the S3 bucket and then delete it. Option D. Replace the EC2 and S3 bucket resources with a single AWS Ops Works stacks resource. Define a custom recipe for the stack to create and delete the EC2 instance and the S3 bucket. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company hosts a security auditing application in an AWS account. The auditing application uses an IAM role to access other AWS accounts. All the accounts are in the same organization in AWS organizations. A recent security audit revealed that the users in the audited AWS accounts could modify or delete the auditing application's IAM role. The company needs to prevent any modification to the auditing application's IAM role by any entity other than a trusted administrator IAM role. Which solution will meet these requirements? Option A, create an SCP that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the SCP to the root of the organization. Option B, create an SCP that includes an allow statement for changes to the auditing application's IAM role by the trusted administrator IAM role. Include a deny statement for changes by all other IAM principals. Attach the SCP to the IAM service in each AWS account where the auditing application has an IAM role. Option C, create an IAM permissions boundary that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the permissions boundary to the audited AWS accounts. Option D, create an IAM permissions boundary that includes a deny statement for changes to the auditing application's IAM role. Include a condition that allows the trusted administrator IAM role to make changes. Attach the permissions boundary to the auditing application's IAM role in the AWS accounts. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is using AWS code pipeline to automate its release pipeline. AWS Code Deploy is being used in the pipeline to deploy an application to Amazon Elastic Container Service, Amazon ECS, using the blue-green deployment model. The company wants to implement scripts to test the green version of the application before shifting traffic. These scripts will complete in 5 minutes or less. If errors are discovered during these tests, the application must be rolled back. Which strategy will meet these requirements? Option A, add a stage to the code pipeline between the source and deploy stages. Use AWS code build to create a runtime environment and build commands in the build spec file to invoke test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option B, add a stage to the code pipeline between the source and deploy stages. Use this stage to invoke an AWS Lambda function that will run the test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option C, add a hook section to the code deploy app spec file. Use the after allow test traffic lifecycle event to invoke an AWS Lambda function to run the test scripts. If errors are found, exit the Lambda function with an error to initiate rollback. Option D, add a hooks section to the code deploy app spec file. Use the after allow traffic lifecycle event to invoke the test scripts. If errors are found, use the AWS deploy stop deployment CLI command to stop the deployment. Correct answer is option C. You You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a DevOps engineer needs to apply a core set of security controls to an existing set of AWS accounts. The accounts are in an organization in AWS organizations. Individual teams will administer individual accounts by using the Administrator Access AWS Managed policy. For all accounts, AWS CloudTrail and AWS Config must be turned on in available AWS regions. Individual account administrators must not be able to edit or delete any of the baseline resources. However, individual account administrators must be able to edit or delete their own trails and AWS config rules. Which solution will meet these requirements in the most operationally efficient way? Option A, create an AWS Cloud Formation template that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using CloudFormation stack sets. Set the stack policy to deny update delete actions. Option B, enable AWS Control Tower. Enroll the existing accounts in AWS Control Tower. Grant the individual account administrators access to CloudTrail and AWS Config. Option C, designate an AWS Config Management account. Create AWS Config recorders in all accounts by using AWS CloudFormation stack sets. Deploy AWS config rules to the organization by using the AWS Config Management account. Create a CloudTrail organization trail in the organization's management account. Deny modification or deletion of the AWS config recorders by using an SCP. Option D, create an AWS CloudFormation template that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using CloudFormation stack sets. Create an SCP that prevents updates or deletions to CloudTrail resources or AWS config resources unless the principal is an administrator of the organization's management account. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has an application that runs on Amazon EC2 instances that are in an auto-scaling group. When the application starts up, the application needs to process data from an Amazon S3 bucket before the application can start to serve requests. The size of the data that is stored in the S3 bucket is growing. When the auto-scaling group adds new instances, the application now takes several minutes to download and process the data before the application can serve requests. The company must reduce the time that elapses before new EC2 instances are ready to serve requests. Which solution is the most cost-efficient way to reduce the application startup time? Option A, configure a warm pool for the auto-scaling group with warmed EC2 instances in the stopped state. Configure an auto-scaling EC2 underscore instance underscore launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option B, increase the maximum instance count of the auto-scaling group. Configure an auto-scaling EC2 underscore instance underscore launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option C. Configure a warm pool for the auto-scaling group with warmed EC2 instances in the running state. Configure an auto-scaling EC2 underscore instance underscore launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook when the application is ready to serve requests. Option D. Increase the maximum instance count of the auto-scaling group. Configure an auto-scaling EC2 underscore instance underscore launching lifecycle hook on the auto-scaling group. Modify the application to complete the lifecycle hook and to place the new instance in the standby state when the application is ready to serve requests. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has developed a serverless web application that is hosted on AWS. The application consists of Amazon S3, Amazon API Gateway, several AWS Lambda functions, and an Amazon RDS for MySQL database. The company is using AWS Code Commit to store the source code. The source code is a combination of AWS Serverless Application Model, AWS SAM templates, and Python code. A security audit and penetration test reveal that usernames and passwords for authentication to the database are hard-coded within code commit repositories. A DevOps engineer must implement a solution to automatically detect and prevent hard-coded secrets. What is the most secure solution that meets these requirements? Option A. Enable Amazon Code Guru Profiler. Decorate the handler function with underscore lambda underscore profiler function. Manually review the recommendation report. Write the secret to AWS Systems Manager parameters stored as a secure string. Update the SAM templates and the Python code to pull the secret from the parameter store. Option B. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secret from AWS Secrets Manager. Option C. Enable Amazon Code Guru Profiler. Decorate the handler function with underscore lambda underscore profiler function. Manually review the recommendation report. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secret from AWS Secrets Manager. Option D. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Write the secret to AWS Systems Manager parameters stored as a string. Update the SAM templates and the Python code to pull the secret from parameter store. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.